In this next session, hear about the Netflix journey to improve its cloud storage efficiency, including the phases of ingest, production, mastering, and long-term storage. Learn from Netflix's best practices, which have been developed throughout each phase of the production cycle to improve efficiency and lower storage costs. Please welcome Vinay and Isha from Netflix. Team, it's all yours.
One, two, three. Okay, yeah. Okay, good afternoon, everyone. Today we are going to talk about optimizing cloud storage, and we are going to look at the best practices that we have from Netflix at a very high scale. To start with, let's look at the agenda, and we'll follow this. I'll introduce myself and my team. Then we'll look at the life cycle of studio content creation. We'll look at the statistics that we have collected so far, and these are data usage patterns and data growth patterns. Next, we'll look at the requirements that our team came up with to solve this problem. Then we'll look at our solution. Isha will deep dive into the engineering problems. And then we'll follow up with, estimated savings and summary. A little bit of myself. My name is Vinay. I work at Netflix in the media infrastructure platform. I do storage abstraction on top of S3. So we have all the internal Netflix apps talking to this abstraction instead of going to the S3 cloud. And the topic that we are going to cover is the smart storage algorithm. And this is related to how efficiently we manage all the studio content that gets ingested into Netflix. So let's look at the life cycle of the studio content creation. I think most of you are familiar with what goes from creating the script until the launch. So here we are showing that when the screen from the time when the script gets green-lighted to the time when it gets launched, there are a lot of artist studio parts involved. So the key thing to notice here is there are a lot of upload downloads happening at every phases, and every artist at every phase is creating a backup just to they're worried about their data getting lost and all that. And as you see this, there is at every stage more data gets collected and backed up, and it goes into the media cloud storage. And that's where the problem arises, that this data is growing at an exponential rate, and we have to address that. So these are the two stats we have collected. The first one is the data growth pattern. We have seen that our data has grown 100% year over year. So we are doubling our data catalog every year. And there are various factors to that. We are producing more content. Last year we created 800 titles, and we licensed about 9,000 more. And that is a huge number in petabyte scale, right? Next, we have expanded geographically into different countries. We now produce content in 65 different countries. And that requires us to integrate with a lot of vendors in each country. So we have about 4,000 plus vendors integrating with our system. And we're talking about a lot of content being created, back and forth uploads and all that. Next is the cost increase. As a result of data increase, we have seen 50% increase in our cost. So year over year, we have seen 50% increase for the past few years. And key thing to note is that our 40% of data that gets ingested never gets used in the final cut. So we're talking about a lot of data and a lot of money involved in when it comes to not using the data that we have ingested. Let's look at the next metrics that we collect. This is the usage pattern or access pattern. And what we have seen is until the day of launch, we access about 53% of the data. And these numbers, they die immediately after the launch. So you will see that after 1 month, the user access gets down to about 8%, 5%, and so on. So a lot of data doesn't get accessed immediately after the launch. And this stats helps us in categorizing our data, like, what data needs to be in active tier versus what data needs to be in a low cost effective tier. So based on that, me and my team came up with some requirements that our system should have. And these are some of the high-level requirements. First and foremost, we wanted it to be a policy-based automation. What I mean by that is we wanted to have our customers with a set of rules that they can attach to assets. And these rules can be move data to different tiers after 30 days or something like that. And we want this to be an automation because we're talking about a huge number of shows here. And once the customer has, once our client has attached the policy, it becomes an automation and it will follow its life cycle based on, whatever the rules dictate. Next, we wanted the authorization. We have a lot of our stakeholders like product managers, technology managers, app owners that want to customize these policies and rules. We want to collect the insights that we have collected so far and even go beyond that. So we have deep integration to understand the storage and usage patterns. Next, we wanted a very granular object-based data tiering. We wanted to dictate which object goes to which tier or gets purged at every phase. Next, easy retrieval process. The data that gets archived is not available for access immediately. So we wanted ad hoc retrievals so that our artists are not blocked. And, whenever you want to get some data out, you should be able to do that. Auditing is important for us. We wanted to do that to understand how our policies are behaving, at what time our data gets moved to different tiers and all that. And another key requirement that we had was, ad hoc bulk movement of data. Historically, we have stored all our data in one storage class. So, and we have accumulated about hundreds of petabytes there, and we wanted to bulk move from one storage tier to multiple storage tier, and that's where we needed that. Another aspect to that is many times our content insights showed that some shows are trending, some shows are not, and it did not make sense to keep the data in a high tier or active tier if a season is not if a show is not going to see a next season. So we wanted a way to short circuit movement of data. So here is a brief view of what we mean by data and data states. So when it is in active state, you are able to read metadata as well as download and play them. Archived is a state where you can read the metadata, but it is not available for downloading and playing. But you'll have to restore it, and at some point in future it will be available for you to read. Purge is a state where we have lost everything. We delete all traces of data, and that's not getting charged for anything. Let's look at the solutions that we evaluated. We looked at S3 offerings just because we are a huge S3 users. So S3 offers a wide spectrum of storage classes, right from S3 standard to S3 Glacier Deep Archive. I have listed only a few that we are interested in here, but if you look at the pyramid, the top part is narrow and it should be in a lesser amount of data needs to stay there. Whereas the bottom part is where most of our data will sit, and it is the most cost-effective tier. Along with that, S3 also offers intelligent tiering. So it is a solution from S3 where it intelligently moves data from one tier to another based on access. And though this solution is great, but when it comes to Netflix at petabyte scale, these things, there are some things that it lacks, and these are the things. We wanted a more granular control. We wanted to dictate when the data moves from one storage class to another. Next, we wanted a capability to skip the transition tiers. So as I said before, we have more insights, and we would leverage those insights into if the show is not trending, we would move directly to the coldest tier or the most cost-effective tier. Lastly, it cannot leverage the richer metrics, and that's where our product shines, which is the next slide. And this is our final solution. So what we did was we leveraged a lot of S3 storage tiers, and we built a smart solution on top of it. And these are the 4 smart things it does. First is the smart categorization. So what we did was we made sure that right at the beginning, we could categorize our data into different buckets, and our insights help us with that. Next is the custom rules. We did not want to hard code or use the hard-coded algorithm by S3 intelligent tiering. We wanted to make sure that we can move data sooner into different tiers. Easy retrieval has always been our primary requirement. We always do ad hoc retrievals whenever we want to access data. Another thing that is important for us is reusable framework. So we are entering into the territory of unmanaged storage or edge storage. And we wanted all these things that smartness that we have developed to, be useful for all that. This is a estimated savings slide. So if you look at the orange curve or the graph, that would be the X amount of X $1 million we would have spent by 2025. That's our status quo if we had not done anything. And if you look at the pink graph, it's a short-term solution. We moved all our data to Glacier instant retrieval. And that gave us a good solution, which is an interim solution where we did not pay the penalty of latency or anything. But the green line is our North Star, and that's where we are at. And we could achieve about 70% of total savings. And this is dictated by, our policy rules and more granular control over it. So net we have made possible of 70% savings in all. And we are on our way till 2025 for that. So next, Isha will present our deep dive into our engineering solution.
Hello, everyone. Thank you, Vinay. I'm Isha. I work for the media infrastructure and platform team at Netflix. Continuing on what we have learned so far, we know that data lifecycle management is crucial for cloud storage efficiency and sustainability at scale. Let's learn how we solve this problem at Netflix. So let's first look at our studio storage ecosystem at Netflix, how it looks like. At Netflix, we have many applications that work with studio assets or data. Most of these applications run in AWS Cloud. What sort of applications? These applications are metadata services, authentication authorization services, our asset management services, or some pipelines we have built to run our workflows. Basic building blocks used in any studio ecosystem. When it comes to data, these media assets are what being used to produce the final content that you see at Netflix streaming platforms. So what is an asset? An asset is a file or a list of files that are generated during production or post-production workflows. So these assets could range anywhere from one file to millions of files. And these assets have nature. Some of these assets are hotter than the others. Some are ephemeral. Some have different level of importance based on their time or their versions. With that information, we have come up with a production workflow where you could attach lifecycle policies with these assets based on their importance and drive their storage tier. So what is a policy? A policy, as we mentioned before, is a set of rule or procedure that dictate where the data should be stored. So let's look at our storage lifecycle management architecture, how it looks like. Our storage lifecycle management architecture has following components. It has a policy console. It's a UI to define policies or view the dashboard on top of policies. Our policy manager, which is a backend service to store the metadata of the policies. And our content drive, which is our core storage infrastructure layer to store the metadata for all the media files at Netflix. And then we have S3 object manager and object mover, which work closely with our Amazon S3 and provide us some data abstractions to authorize our data along with Amazon S3. So we have various actors that are interacting with the system here: product manager, application owner, or technology manager. They are the ones who work with the system to create the metadata, to track this metadata, to run workflows on top of this metadata, and drive the policies to move them to different storage tiers. And we have various backend applications that interact with the system. So once the asset gets ingested into the Netflix ecosystem, it is stored in AWS S3 as objects. And at Netflix, we just store the identity of all these objects along with some essential metadata that we need. So let's look at all these components in some detail. First, policy console. As I mentioned, policy console is the API layer. It is used to manually or automatically define and attach lifecycle policies with the assets. So it also provides the UI dashboard to visualize or monitor cost on top of these policies and view the policy execution, how it is affecting our asset lifecycle. Next is our policy manager. This is our backend system which stores the policy metadata and allows us to evaluate and trigger the lifecycle operation. It has a component which is policy execution engine. It continuously evaluates which lifecycle operations can be applied to which assets at what time. Once it determines which lifecycle policy is applicable to any asset, it triggers the effective policies with the content drive. So an example of policy could be to archive an asset 30 days post its title's launch date. So once this policy is defined, on a title launch date, policy manager will evaluate the policy and then trigger the lifecycle operation on the applicable assets and send the execution of those policy operations to content drive. Content drive is our core storage infrastructure layer, which manages the metadata for all the files and folders at Netflix. It has a scale at billions of files. It empowers our studio partners and users to ingest data at Netflix, to define lifecycle policies, to store and track all this metadata and do hundreds of things to access control over all these assets, files, and folders. It is backed by our S3 manager, which is a storage abstraction layer on top of S3. Amazon S3 Object Manager is a storage abstraction on top of S3. It handles the authorization. It basically converts the internal credentials into Amazon IAM roles. It also computes file level checksums or object level checksums and provides some extra features on top of Amazon S3. For example, handling more concurrent requests and providing faster access to the metadata requests. Our Amazon S3 Object Mover is a thin abstraction which helps us tagging the objects with the right storage tier. It helps us move data from one storage tier to the another, and it handles the request asynchronously. Okay. Finally, the main component that we added as part of this smart storage algorithm is Data Lifecycle Manager. Our Data Lifecycle Manager is the orchestration layer which orchestrates all the lifecycle operations such as archival, restoration, and purge operations on the media files and it has an ability to aggregate many files into a single task. Remember, an asset can consist of millions of files. So each of these lifecycle tasks can consist of millions of files inside it. Data Lifecycle Manager handles all the requests asynchronously. What I mean by that is all the lifecycle operations are persisted in the DB and then triggered asynchronously. To achieve the required throughput, what we do is we shard these tasks across all the nodes in the cluster with only one node working on a task at a time. By sharding the workload, this solution also avoids DB transaction conflicts. We use Kafka to send the events related to a particular task to the node that owns the task. This way, only one node will work at a task at a time. With you can have the concurrency of millions of tasks working together in this system in a distributed fashion. Even with that concurrency and that level of SLA, we can see that this solution avoids the DB transaction conflict and it provides us the right amount of throughput. So let's look at an example of archive workflow to know how these components work together. Studio application create and define policies, as we mentioned before, and policy manager keeps evaluating which lifecycle operation can be applied to which asset at a time. An example of policy, as I described before, was to archive an asset 30 days post a title's launch date. So these policies will be predefined, and then once policy manager looks at the title launch date, it will trigger the archival of assets belonging to that title. So once it triggers the archival of those assets with content drive on receiving that request creates a task with this data lifecycle manager. What I mean by creating a task is we persist the information that this task of archival needs to be triggered 30 days post its creation. So now at that time, Storage Lifecycle Manager persists this information and then decide the shard ID for the task. Storage Lifecycle Manager has components that continuously keep evaluating which tasks are eligible for execution at a time. Based on the task's execution timestamp, it starts the execution of that task with the content drive. And then content drive collects the archival objects which needs to be archived as part of the task and sends that list to the data lifecycle manager along with the finalized event after that. So at this point, data lifecycle manager has all the information related to the task, which means it has all the files that needs to be archived as part of that task. Once data lifecycle manager has the list of all the files belonging to the task, it continuously sends archive object request to our S3 object manager layer. It does that in a concurrent fashion. And along with that, our S3 object manager layer also archives those objects in a concurrent fashion. Once S3 object manager has archived certain object, it keeps sending per object level events back to the storage lifecycle manager, indicating whether the archival of those objects was successful or not. Our storage lifecycle manager layer keeps evaluating whether the task has completed or not. Because a task has an aggregation of millions of files, it needs to figure out whether all the files have completed or not. So at every message consumption from the S3 object manager, it sends an internal event to the task, to the node that owns the task. Remember, we do the task sharding using Kafka so that we don't run into DB transaction conflicts. So once data lifecycle manager determines whether the task has completed, which means all the files have successfully transferred or not, it sends a completion event back to content drive, and content drive generates a task failure or successful event. This is how we drive the archive workflow using this smart algorithm. Some of the highlights that I want to mention here that based on this algorithm, we have already archived in last 6 months about hundreds of petabytes of data. And if you look at our restore numbers, which is very low, which means that our previous theory of data access pattern was correct. And we are successfully archiving what we are supposed to archive. And with this solution, we have also purged the unused data. About 40 petabytes of data we have purged. We have a lot of future applications of this solution where we want to extend the lifecycle management solution to hybrid storage. Netflix is getting into having data on the on-premise storage where it also manages the show while they're in production. So we also want to extend this lifecycle management solution to manage the data on those on-premise storage. And we also want to provide our studio partners with the functionality to tag and delete the data, to be more proactive about deleting the data that is not needed anymore. And then we also want to extend this solution to do the metadata tiering. Remember, we deal with the scale for metadata at billions of files and folders. We also want to provide predictable SLAs and availability and durability of our internal storage solutions. So we want to do metadata tiering as well. To summarize, by tapping into our AWS vendors multi-tier solution and complementing it with our in-house smart storage algorithm, which is based on user access patterns, we have built a custom, reusable, a cost-effective data lifecycle management solution, which is scalable and extensible and ready to meet the needs of our ever-growing media industry. Thank you so much.
All right. So we do actually have time for a couple of questions, if anybody. There we go. Excellent.
Thank you. Yeah, just a quick question. So when you do the tagging, I'm just curious, number one, who does the tagging? And then two, can you tag it by a group of media, or do you have to tag every asset on its own? For example, any episode from this season of Suits. Yeah, so just curious.
So tagging will be another module that we are building on top of this. And tagging is done by studio partners and applications. And as you mentioned, they can group the assets into a high-level construct, which could be a title or which could be a type of asset. So it provides them all that capability.
It makes it a lot easier too, right?
Yep.
So yeah, thanks.
We've got time for maybe one more question. Who's going to be brave? Oh, there we go. I've never seen so many photos taken of a presentation. Here we go.
Just curious, can you say roughly how many buckets you have in play that are kind of orchestrating this whole, that you're kind of orchestrating across here?
You mean the S3 buckets? We have, I think there are close to 45 buckets spread across 5 different regions. So whenever we start producing content in different regions, we have to create buckets there. And this is a lot of legal stuff there that, snowballs can only be shipped to the buckets in those regions and all that.
Thanks very much. So, Isha, Vinay, excellent session. Thank you very much. I think they deserve a round of applause.